So today we're going to be working on 7-4, dividing by a whole number. So we've already done dividing whole numbers by whole numbers, but today we're going to divide a decimal by a whole number. Okay? So we're going to use the same things we've already learned before, and we're going to apply them to decimals. So let's find my page. Oh, I didn't update my table of contents. So I need a table of contents is going to be page 44. So we're going to have 7-4 divided by a whole number. My essential question is going to be how can you write a quotient with a decimal? All right. So, what does quotient mean? Go ahead, Araya. It's the answer of a division problem, right? So how can we write the answer of our division problem or our quotient as a decimal? Do you guys think we can have remainders when we deal with decimals?
Yeah.
No. So that's what we're going to learn how to do today is divide without the remainder. Okay? And we're going to do something that's called annex of zero.
Oh, cool.
Yeah, it's actually pretty easy. So if you're not caught up to this point, go ahead and pause the video and then catch up and then restart the video whenever you're ready. I just had our example. So here's our example. The first example we're going to do is alright, first example is going to be 24 and 67 hundredths divided by 4. Okay, so we need to rewrite that into what? The standard algorithm. And the way we do that is (24 and 67 hundredths). So this is really important. The first thing we need to do when we divide is we need to bring our decimal point up onto our bar, okay? So it goes right lined up in place, okay? When we divide a whole number, when we divide a decimal by a whole number, that's only guys, look at me. Decimal by a whole number, it goes right up there in place. If we're dividing a decimal by a decimal, we have a different rule, and we'll learn about that tomorrow, okay? So this rule is only for decimal by a whole number, okay? Does that make sense to you guys? So what is this rule for? What if it was a decimal by a decimal? You'll learn about that tomorrow. There's a different rule, okay? It's really simple. All we're doing is moving decimal points. But for today, all we need to know is focus on this, okay? So, after we figured out where our decimal point goes, what do you think is our first task? Go ahead, Liliana.
To see how many times 4 goes into 2.
Okay, exactly. Just like we would normally divide now. Remember how we multiplied normally once we knew where the decimal went? We divide just like we would normally divide now that we know where our decimal goes, okay? So, does 4 go into 2? No. Does 4 go into 24?
Yes.
How many times?
6.
6 times. 4, what is it? 4 times 6 is 24. Bring down the 0. That gives me 6. Does 4 go into 6?
Yes.
How many times? Once. Minus 4 gives me 2. Does 4 go into 2? So we need to bring down this, brought down the 6. We need to bring down the 7, right? Does 4 go into 27?
Yes.
How many times? 8 times. Sure about that?
No, it's 7.
No, it's 6. 6. 6 times 4 is 24. Has 3. So we can this is where we need to pay attention. So everybody look up and stop writing for a second. We can't have a remainder of 3. So this is where we need to figure out what we need to do. And we're going to do something that's called annex a 0. Okay? So we're going to add a 0 here. And then we're going to bring it down. Because remember how whenever we added zeros to the right of our decimal, it's the same value? Okay? So we're going to bring it down. Does 4 go into 30? 7 times, right? 7 times 4 is 28. So we have 2 left. So what do you think our next step's going to be, Olivier?
Then you put another 0.
Another 0. Good job, dude. Another 0. Bring it down. That's going to give us 20. Does 4 go into 20?
Yes.
How many times? 5 times, right? 4 times 5 is 20. A remainder of 0.
Yes. That's gonna take a while for someone.
Okay? Now, you guys personally shouldn't have many problems that go this long. This is the example, though, okay? Yes, Antonella.
So we have to do annex 0 until we have no remainder.
Yeah, you have to annex 0 until you have no remainder left.
That sounds easy enough.
Easy enough. Okay? So let's go ahead and do... I'm going to do one more example with you guys. And then I'm going to try to set you on your own and see how it goes, okay? So my next example is going to be, and it's actually in the book, but we're going to go over it. It's going to be we'll make that number 2, and then we'll do, it's going to be 180 divided by 8. Okay, go ahead and set that problem up. We need to write it in our standard algorithm form. 180 divided by 8. Make sure we're setting this up right, okay? Is everybody caught up?
Yeah.
Okay, so we need to divide this without a remainder. We need to divide this with a decimal if it doesn't go in there easily, okay? Does that make sense to you guys?
Yeah.
So the first thing we're going to do is what?
See how much times 8 can
See how many times 8 can go into 1. Oh, can you guys not see it? I'm sorry. There we go. See how many times 8 can go into 1. How many times can 8 go into 1?
0.
0, right? Does 8 go into 18?
Yes.
How many times?
2.
2. Make sure we're keeping everything lined up. 2 times 8 is 16. That gives me 2. Does 8 go into 2? No. Does 8 go into 20? Yes. How many times? Twice. 2 times 8 again is 16. So we can't have a remainder here of 4. What do you think we need to do to turn this into a decimal? Yes, Hayden.
Annex 0.
Okay, so we're going to add a 0. But before we add a 0, what do we need to put so we don't change the value? Go ahead, Aaliyah. A decimal point. So if we put a decimal point in our dividend, where do we need to put a decimal point here, right? Okay. So now we can add the 0 because now we're not changing the value of 180. If I added a 0 before I put a decimal point, would I change the value of 180?
Yeah.
Yes, because that would be 1,800, right?
Yeah.
So then I bring that down. Does 8 go into 40?
Yes.
How many times?
5.
5, right? Minus 40. 8, 5 times 8 is 0. And then you're finished. So your answer is 22 and 5/10. How do you guys feel about this?
I feel good.
Okay. So, do you want me to do some more examples, or do you just want to try some on your own?
Try it on our own.
Try on your own? Okay. So then you guys are going to work on guided practice. And you're going to do number 1. Alright, let's do guided practice a little weird. Let's do number 1 through 4, but I'm going to add some independent problems, okay? So I want you guys to do page 164 to 165. And I want you guys to do 1 through 7. Okay, but that goes in the independent practice, okay? Does that make sense to you guys?
Yeah, that makes sense.
And then for independent, can you see it all the way down here? Yeah. Independent practice. That's going to be on page 165. Let's do 10 through... I originally was planning at 10 through 20. Let's do 10 through 25 and just see how far you get, okay? Maybe if you work hard and get far enough along, I won't assign any for homework. Does that sound okay for you guys?
That sounds awesome.
Alright, so everybody knows what we need to be doing right now, right?